So I am a contractor freelancer, and I started grading inside my company a couple years back. Before that, I was working mainly in autonomous vehicles, motorbikes, boats, cars, anything related to that. And yeah, 2 years ago, I decided to start my own company just to see a little bit how I like this thing, because I feel like what drove me to make that decision was that I always saw that when I was the most productive for my clients and when I was learning the most, it was at the beginning of a new job, and I felt like talking to more people and seeing what they would want was the most interesting career path for me. So here I am.
Amazing. Okay, so my first question for you is we hear the term computer vision. Can you kind of explain to me what is computer vision and how does it all work?
Computer vision, it effectively means extracting information from visual imagery, that being images or videos. When we have a computer vision project, we normally look it in what can we do with it. So let's start with the image. Then we have some model that it extracts some sort of information. The most common ones are object detection models. And what that means is that we get a bounding box out of the image. So imagine that this fit is the image that we are processing. So what you would get is like a bounding box saying like, this is a face. That's the output of a typical object detection model. And then with that, we can do a lot of different things. Imagine, for example, here, what we could say is like the human is in the middle of the frame. Therefore, it's going to be in the foreground, how much it can occupy of the entire image, and a lot of different interesting metrics that we could get just by looking at the bounding boxes and for different elements that we have. Like we could say like this part here, it's an image, like this is a portrait or whatever. Like we would get like different bounding boxes, and then we could play with our information in order to extract as much interesting insights as possible from that particular thing. So if adding a camera to a computer is adding eyes, adding the computer vision capabilities would be something like giving it the brain to interpret those images. Something that I find that's particularly unique in the field of computer vision when we are talking about AI in general is that we humans are very, very good at computer vision because our brains have evolved over long periods of time in order to understand different shapes and different patterns in order to understand what's that. Like a classical example and one that I particularly like is a cat. A cat could take pretty much any form. It's super flexible. It could put like a leg behind his head. And we humans, we understand what's a cat, no matter what's its color, what's its illumination, what's its position. No matter the condition, we can always distinguish what's a cat. For a computer, that is not so easy. And with the power of computer vision, we can allow them to get these sort of capabilities of understanding what is not only a cat, pretty much anything that we see in an image.
Can you had me at cat? I have three. Can you tell me why do you think there is an urgency for businesses to adopt computer vision technology?
So, in terms of urgency, I would say that there's two big things that have changed in computer vision in the recent years. First of all, is how we approach computer vision, and the other one is advancements in transformers. Let's start with the first one. Let's think about what is a computer vision model and what does it require. So let's say that we are trying to detect a face. Why not? That's what we have in hand. Let's use it. We have a set of images with faces all labeled, which means that they have a bounding box around it. So someone needs to go and draw these bounding boxes. And that's the information that we give to our model. So imagine at the bottom, let's say that's where we input our images, and at the top, that's where we actually get our answer. Like say, like there's a face or there's not a face. What we start passing like all the images here, when we are training the system, what's going on is that we are creating some set of intermediate features. those, after passing like a lot of different examples and a lot of different phases, all with their respective bounding boxes, what we would see is that it's starting to learn some sort of intermediate features. What would they be? Like the eyes, the ears, the nose, the mouth. And to be 100% accurate, this is not what the model would learn, but it's going to be some sort of intermediate feature that, thinking it this way, like that's the way that we humans create the visual features, but the model is going to do something very, very similar. So that's the classical way. We need a lot of data in order to train the model. Why? Because it needs to create all those intermediate features in order to actually get a response, get a detection. Is there a face or there isn't? So what's the new advancement? In recent years, what we've seen is that there's quite a lot of what's called pre-trained models. What's a pre-trained model? A pre-trained model is a model that already has been trained to detect a wide range of objects. Let's say a human, a car, a dog, pretty much anything. Like one of the most common data sets, just to give an example, is called Coco, and it has 80 different classes, so 80 different objects that it's detecting. When it's training, what it's doing is it's learning a very diverse set of intermediate features. So now, if we want to detect a face, we don't need to start building them from scratch. We already can use the features that they have trained, and we need number of labeled images that's much lower than what it once was. Imagine that if before we needed like something like 10,000 images, maybe now we need like 1,000 or even less. I mean, those numbers vary greatly in terms of the application and so on, but like 10x reduction, 20x reduction, that's the things that we have observed in real world scenarios of leveraging pre-trained models instead of starting to train from scratch, because building those intermediate features takes a lot of data, and leveraging those, it's something that not only saves us a lot of time but a lot of money, because building a big data set is very costly. And yeah, that's one of the big things that maybe urge the business owners in order to adopt technology, because now it's not only cheaper but faster. So you can prototype, design, and see the results a lot faster, which I think is like pretty much what every business owner wants. And the other one is transformers. We all heard about ChatGPT, and the technology that powers it is called a transformer. What a transformer is, it's effectively a deep learning block, to call it like that it understands relationships very well. This is normally called attention. Let's put first a quick example with text. Like when we are talking about text and we talk about attention, it means that it knows which word is related to another one. So let's say, like, if you're talking about like Tim is going to the beach, he is tall, something like that, you would know that he and Tim are referring to the same entity. Then for when we're talking about images, what we have is a visual transformer. What that empowers, or what that allows, is that we also have this sort of attention. So let's say that we detect some eye. It would know that if the model has been trained and everything, that it would require to have another eye in order to have a face. So there are certain modifications that can be done in order to understand very well and to detect in a more accurate way. So let's recap. The first one, it's about the new ways of training, which are cheaper, faster, and yield results in a cheaper and faster way. And the second one is that we now have the transformers, the building block of ChatGPT, now powering also computer vision models. And what that yields, it's better performance and more accurate models.
How do you think that software and tech companies can actually utilize this computer vision technology to enhance their user experiences and also to deliver like more personalized services?
So there's quite a lot of different options, because the advancements that we just talked, they don't only allow a gradual improvement, there's also a new set of things that now are possible that they weren't possible a few years back. Like, let's put, for example, now what we could do is like get an image and get a very accurate caption, like a description of what's going on in the image. That has a very wide range of capabilities. It could be understanding what sort of data do you have in your data set. It could be extracting certain insights from images that your users give you. That's one of the ones that we could talk. Another one, and one of my favorites, is a visual search. We all have seen Google Lens, which is that we take a picture and we give it to Google, and it tells us what's similar to it, and if it's a product, where you can buy it, and things like that. Imagine that, for example, like an e-commerce site. If I take a picture of my sweater and I'm trying to find something similar, like then I can do something like that. But it doesn't need to stop there. Imagine it could be like for the pattern, the color, it could be about the style of the zip. It could be many different things. Like, it just depends what the client deems to be the most important for their users. But those are all things that are empowered by using computer vision in software and tech companies. Aside from that, you could get like something a bit more immersive and realistic. One of the technologies that I find quite interesting is like for VR. It's not only for VR, also applies for AR or augmented reality. What you see is that you need to have a very good detection of where your goggles are in space in order to project things into it. And these things, like even like with the latest virtual reality headsets, what you see is that they use visual features in order to locate the images and see how it's actually moving. So it's not only accurate, but it's very, very fast and very precise. And maybe it's like one of the less well-known features of computer vision by the general public. In general, there are other ones like quality control, inventory management, traffic analysis, even medical diagnosis. What I feel is interesting is like everyone can see, so everyone can kind of get an idea of what could be a good idea.
Okay, so imagine you're talking to someone who doesn't really have like a technical background. And if you're trying to explain to them like the practical steps that they can take as a business to effectively implement a computer vision project into their organization.
I feel like the first step is what we just talked, is to use your eyes, see what you can distinguish in your company, your processes, whatever it is that you are doing, and see like, look, I could actually extract some information just by looking into it. And this is something that could be leveraged down the line for whatever. It could be like detecting defects, like security reasons, like we just talked about applications. But if you can detect it with your eyes, probably computer vision can detect it. And what's interesting is like the computer doesn't get tired, so like you can do it for a very long period of time, so it's easy to extrapolate for something bigger. Then the second thing would be about the infrastructure or the setup. And what I mean by that is that we talk about pre-trained models. So there's a lot of models that they are available online that we could leverage in order to detect certain things. Let's say we're doing something to detect sweater. And we know that even that in our data set, all the images of sweaters are when the humans are wearing it. So if I have a model that it can detect humans, which is what we already talked about, it's a pre-trained data set. So we have that. So we can just crop the image to below the neck, and we have more or less where the sweaters can be. So it's an easy way to start building the data set. That's one of the most important things. Identify where you are, think something that gives you value straight away, and you can start building the data set. And then is when you kind of start training the model to get the awesome results. When you have that, then it's just a matter of iteration. And something that I feel like it's very important in all the projects that I worked on is that we define some sort of metric that truly impacts the outcome of the project, meaning that it's the client, the one that chooses it. The most classical is the ROI, but it could be like, I don't know, how many more sales you get when someone uses your tool or something like this. The beautiful, the nice thing is that you can implement pretty much anything, and it could be something that's truly meaningful for the client or whoever is actually implementing that, and doesn't need to be like something so abstract like what's the mean average precision or some like data science term that the client is not actually going to care about. It's like it's going to be a metric that they actually going to care. And yeah, those are the main steps.
I think that's so important. You touched on the ROI, and could you kind of like highlight what do you think are the long-term benefits associated with investing in computer vision technology for businesses? So, like, what is the ROI?
Greatly depends on the project, but some formula that I like a lot and I feel like it kind of presents a little bit about this basic calculation is that we have 2 points of return in a computer vision project, because what we do first is we try to find some sort of model, like the example that we just put about detecting shirts is an example, but it could be a lot of different things. Like there's we could use captions or things like that to detect actions or whatever it is that we try to do, but always try to leverage some technology that's already available to give value straight away. So what that makes is like pretty much all the projects, they're going to have a very positive ROI. Why is that? Is because we can validate them extremely fast. By creating this minimal viable product, we are making sure not only that the client is going to be happy with what we are doing, because we are validating that the metrics that he cares about, they are taking care about our work, but it's also that we can actually start building the data set that we're going to use later on. So with that example of like the shirts, we can start getting some sort of basic detection. And then we are starting to build also a data set with the actual pieces of clothing that we need to train our model. So once we have the data set, those are the two main key points that drive massive ROI in the long term. Is like first give value straight away and make sure that the metric that the client wants is tackled by us or by the computer vision provider. And the second one is that we are starting to build a data set that it's something that we can build upon. Because now what we have, once we have the data set, is that we can start training, start iterating, but we already have integrated our system with the client. So now it's going to be like a massive improvement, but it's not going to be a lot more effort from the client. So at that point, it's just like improving until the one that's implementing computer vision has good enough results for their product, and it's happy with the result, which I think is what everyone cares at the end of the day. Just making sure that you are maximizing the results, but it's just in a simple way to make sure that you're gonna get a satisfactory outcome to validate it as fast as possible.
I'm going to put you a little bit on the spot here, and I'm going to ask you if you can give me an example of a project that you've worked on, what their key metrics were, and what was the kind of ROI that they achieved.
So there's a few different projects that I worked on, and that I'm just thinking which one would be the most relevant. So, for example, there's one that I actually like quite a lot, and that it was about creating a system, imagine like Google Photos, but instead of just scrolling through your images or typing like cat, dog, or something, and you get images of that, that you can talk to it, that you can ask what sort of information you want. If you want pictures, I don't know, with you, with your husband in Italy drinking wine or something like that, you can write it like that, like a sentence, like you would ask someone that is actually searching for you, and then you start to see it. And this is kind of the things you can do, because like you extract the information from the images and then you can compare it to the text input that the user gives you. And what we were using in that particular project was simply to see the engagement of the users, because at the end of the day, it's not only about money. It's also seeing how they are engaged, and that's going to make sure that they come back to your platform. They're gonna stay there in the long run, and they're gonna pretty much find the utility of it. And what we've seen is that since that point that we integrated that capability, that there has been like a massive spike in terms of like using the app, just because like it has something that's quite cool. Like you get to search in your images by natural language, so you don't need to actually scroll for minutes and minutes just to make sure that you find some picture that you don't even remember when you took it or what was exactly there. Like any description does the trick, and that was very useful. And again, like, to be fair, it was not only engagement, because it had other sort of features that that it had integrated with it, like buying things and stuff like that. So what I mean is, like, when the client was more interested in the engagement because they knew that the sales would come afterwards. So it was interesting to see that we could increase one and increase the profit as a consequence.
When you implement kind of these projects, these computer vision technology projects, why do you think it's important for top level executives to prioritize this into their business strategies?
First of all, I would say that the efficiency that you get from computer vision, it's something that pretty much distinguishes from a human. We touched into it before, and we said like humans are very good at distinguishing different features and recognizing what's going on in a video and so on. But how long can they do that reliably? Like if you are looking a screen for 10 minutes, you can do it. You can pay attention fully, sure. 1 hour, maybe not. 5 hours, 10 hours, what's the limit, you know? Like the attention, it goes down, and that increases the risk. It's not always about comparing the accuracy of the detection to a human, but also understanding how long can a machine pay attention for, which is forever, and how long can a human pay attention. And just to put it in the framework of what we were talking before, here what we could do is start and create some sort of like motion movement or human movement and detect this stuff and then alert the actual security guard if it's a security facility or something like that. And with that, we already give value straight away, and we also start building the data set that we gonna need later on in order to go the next level and get all the results that the client wants. Other applications would be improve accuracy, like with the transformer based models. They seem to have like very accurate results, and they can use massive amounts of data. So like if that's some industries, they just have like massive amounts of data that they could tap for this kind of applications. So my point is like there's a solution pretty much for anyone. It doesn't need to be that you have a lot of data or very little data. There's the right solution for pretty much anyone, and that's one of the beauties of computer visions in the current situation. The other ones would be like having a competitive advantage, because now there's a lot of different things that they are possible because of computer vision that they weren't possible even like 3 years ago. Like captioning now is super accurate. Object detection, it's like the most accurate that it has ever been by a wide margin. And probably the one that I feel it's the most impactful is that you can get it ready for cheap. Well, I mean, for cheap is that you don't need a massive amount of data and you don't need a massive amount of compute to train those things. It's accessible for everyone. And finally, like cost savings, like you can go through a massive amount of data. Imagine that how many people you would need to go over a massive data set and extract some sort of interesting insights, like just the very big data and very big volume of data that you can go through with a machine learning model quickly. That's, I feel, quite interesting and appealing for most business owners.
You mentioned data and that you don't actually need to input as much data nowadays because it's already existing. What are these data sets? What data is typically utilized in computer vision applications? And also, what methods are employed to ensure the quality?
So there are two main types of there are two different types of training modes, and they require different types of training data. Let's put a different example. I have here a Mac, and if we were to do what's called supervised learning, we would need label data. That means that we need the bounding box that we've been talking all along, and that we need a lot of images of Macs with different angles, different things, and we would then train a model, and we would have a detector for Macs. That's a labeled data set, supervised learning. That's the main one. And that's the most common one, and now it's very cheap because there's quite a lot of pre-trained models that we can leverage, so we don't need to train everything from scratch. The other mode would be to use what's called unsupervised learning, which is images of Macs, but now without the bounding box. So what do we do if we don't actually have the output? What we can do is we can use certain types of techniques. Like there's two main ones. The first one would be to try to generate the intermediate features for certain types of images. Like there's a lot of data sets with real world images. So anything that you can take with a regular camera, that's pretty much covered. But imagine that you're trying to do something more specific, something that there's not so much data about, like pictures of cells or something like that. Like the feature that you're going to get from an eye and what you're going to get from an actual cell, it has nothing to do with it. Like there is these intermediate features, they don't translate well into the other application. That's when you can start to use unsupervised learning in order to leverage this data, even if it's not labeled. But at some point, you will need a little bit of labeled data. I'm just saying, like, if you have a massive amount of unlabeled, you can use it to make the training easier down the lane. These are the two main types of training data, but the important features is like the quality of the data. What does it mean that the quality of the data? By quality, we refer at different situations. So imagine that you have a very controlled environment, something that is in a factory or something like that. You know that the illumination is going to be very constant. You know that certain positions or reflections are not going to be there because it's like something a lot more stationary. It's not going to change that much. Maybe there's going to be a little bit of a shadow of some operator or something like that. But there's not going to be one day that there's like a lot of sun, the other one that's overcast. The conditions, they're not going to change that much. So in that particular case, you don't want a lot of variation. But if you are trying to do a cat detector, what you would need is a lot of images in cats in very distinct positions, like not only like walking with the feet behind their neck or anything like that. It could also be like different illumination, different poses, different fur colors, different types of cats, breeds, whatever it's called. I'm not a cat person. And then also the quantity of the data. So like if you have enough variability, then the model can start figuring out what is a cat, even if you don't have a lot of data. But if you have a massive amount of data, then this can be actually paid a bit less attention, because like just by having a massive amount of data, you already start to have a bit more variability naturally. So those are the main things for small projects, which are probably the ones that need to pay most attention to the data. I would say like focus on quality. That means high resolution images, very good bounding boxes. What it means, like this, it's too loose. It needs to be as tight as possible to the object that you are trying to detect. And also make sure that the situations encompass all the different situations that you want to represent, illumination, positions, and stuff like that.
Okay, I just want to talk a little bit about security and surveillance. So, how is computer vision being applied to enhance surveillance and security, particularly through advanced threat detection?
So for surveillance, an example, it's one that I mentioned briefly, but imagine what sort of, see, when you have a guard or someone that's looking at the video feed for a long period of time, it's just normal that he's going to get tired, and he's not going to pay 100% attention to all the video feeds at once. It's just impossible. Like, it's not his fault. So what we could do in there would be like start with some sort of detection system that we can leverage to make his life easier, because he doesn't need to pay a lot of attention everywhere all at once. It can say like, look here, maybe there's something. And just with that, you are making his life easier. And also when you're doing that, you start building the data set. And with that, then we can start getting like the impressive results that everyone is after. But pretty much you can do anything with surveillance, because they have a very good perspective of what you're going. Like the camera positions tend to be quite high, and you tend to have a very nice field of view. What I mean is like it's relatively simple to detect humans, cars, and everything, because you have a full view of the entire thing rather than seeing like just the top part and things like that. And that's a massive advantage for computer vision. Then regarding other elements, like for example, you could do like gun detection, and also like now thinking of it, you could do like face recognition, which is quite important to make sure that there's no one that is like in a banned list or any dangerous subjects that you know of, like making sure that there is no immediate threat. And again, like you could have this running for 1,000 cameras. It doesn't matter how many you've got, unless up to the point you have enough compute to make sure that they are all being processed.
If you had a crystal ball and you could look into the future, what do you think we'll see in the next 5 years around computer vision? And I'm talking about like integrating into new industries. What kind of advances are we going to see in the technology?
One of the big advancements that I can see happening in the future is the integration of visual data in the large language models. So we already talked about ChatGPT, but like that's the the hot topic in AI. So basically what that is, it's a natural language model. What it means is that it's meant to process text. Now there is the rise of multimodal models. What do I mean by that? That they don't only process text, but also images, sounds, videos, wherever. And this kind of information can be used not only to get a very good understanding of images themselves, but get an accurate world representation. That's the most interesting thing. So when you get a model now and it's trying to extract information, it's relying only on the visual imagery. But when these big foundational models have been trained and they have been going on for a while, my guess is that they not gonna go only understand the pixels, but they're going to understand the concepts behind it. Maybe that doesn't make too much sense, but let me explain it a bit better. What do I mean by that? Like, you could have novels explaining very, very clearly how trees are, and like the all the different colors, and the disposition and the colors that they get in different seasons and so on. So this knowledge that it's only in novels, that it's only in text, is going to be in the same model that now understands images. So it can be applied by trees, it can be applied by anything. That's the beauty of it. It's not only a model that understands images, it's going to be a model that understands the world. That's what I think is going to be like one of the big improvements in computer vision in the future. But yeah, that's more of a guess than a reality for now. So we'll see in a few years.
Okay, I've got one final question for you. Is when you're talking to top level execs and potential partners to work with, what are some of the biggest blockers that you experience? What are some of the biggest concerns that they have in implementing computer vision technology?
So I always say like that my work as an AI consultant is to tell people when not to use AI, which might seem a bit counterintuitive, but it makes more sense when you start thinking about it. Everyone cares about the latest shiny thing, but making sure that we leverage the small wins, the ones that make sure that we're going in the right direction, having a nice MVP that allows us to validate our ideas, and making sure that we are collecting the right data. That's my main position, like my main focus at the beginning of a project, and I feel like it addresses most of the people that I talk of the concerns that they have, because like everyone is concerned about the same thing. They just want to invest a lot of money and they don't get any results. They want to, first of all, put little money and start seeing results, and that's what this approach does. It's just making sure as fast as possible that we are going in the right direction, and that the thing that the value cares about is what we actually going to take care of.
Okay, I'm going to throw you one more question. Sorry. So there's obviously, you said like some concerns around AI, a lot of fear. People don't know, like especially with like the launch of ChatGPT and how we're seeing it progress really fast. How do you kind of ease those concerns with people?
I am a consultant, a programmer. So like you see a lot of AIs actually doing the programming these days. And this is a concern that everyone has. Like, I don't think there's anyone, probably aside from the health sector, that has like no real impact or no real position for it. But the way that I like to see it is that there's going to be a massive chain of innovation, and it matters where you're going to be. Like, if you look at the Industrial Revolution, everyone was like doing very boring jobs before, and they moved to something a bit more advanced, and the productivity went the very up, and everyone was better off at the end of the day. So that's the approach that I like to see in that particular case. And probably, maybe like, I don't know, in 50, 100 years, like no human is going to be working, but there's a very long way up until then. So like, I think it's smart to put yourself ahead of the curve, use AI as best as you can, so at least you know what's coming. At least you know you are one of the ones that's taking advantage as best as you can, which is what all of us can do, and effectively make sure that you are not left behind in this big revolution.
Amazing. That's exactly what I was going to say. That if you're not going to implement AI, your competitors are. So you don't want to get left behind in the process.
Might as well be you and like try to take advantage of it. There is no going back now.
Amazing. Is there anything else you'd like to add? Do you feel like we've covered everything you wanted to discuss today?
I think your questions were very insightful and to the point. Really enjoy them. And yeah, no, I think you covered everything.
Awesome. Yeah, I definitely have learnt a lot in this session. So thank you so much. And yeah, we'll definitely catch up soon. So thank you so much for your time and wishing you all the best.
Thank you. Have a nice day.